All right, we're back. We are on Calc AB Notes 1, page 2. I mentioned in the beginning of the last video that this assumes a lot of prior knowledge, that you've gone through basically my math analysis notes, and in particular notes 18 to the end. So if this stuff seems crazy to you, that's where you should really be starting. So I'm going to dig in with this, but maybe you need to go back and take a look at that first. But on the previous page, we're using the limit definition to find the derivative of a bunch of functions. Now what we're going to do is kind of review some of the derivative rules that we know, right? So first of all, we know the derivative of a constant. So what might that look like? I'm going to say that's d dx, the derivative with respect to x of c, a constant, is equal to 0. So why is that the case? You could use the limit definition to find that. You could think that y equals c is a horizontal line. Horizontal lines have 0 slope, or a slope of 0, and that's how you get that. Next up, the power rule. So you have to remember a power function. So the derivative with respect to x of x to the n. So a variable raised to a real number is a power function, and the derivative of a power function is really common. So this one you got to really master. You bring the exponent down, and then you take 1 away. So bring it down, subtract 1. So n times x to the n minus 1. So that's the power rule. And then the next rule is the constant multiple rule, which you will never think about, but you will use a lot. And that says that the derivative, excuse me, the derivative of a constant times a function, let's say a function f of x, is going to be equal to the constant times the derivative of that function. So I'm kind of mixing and matching my function notations here. I think it's okay. So you can, you never really think about this one. The derivative of a constant is just the constant times the derivative of the function. Sorry, the derivative of a constant times a function is the constant times the derivative of the function. You will use it a million times. You will never really think about it, but it's a rule. This is another rule you won't really think about, the derivative of a sum or difference. So I'm going to say d dx of, I'm just going to use f plus g, is equal to the derivative of f. So I'll say f prime plus, well, sum or difference. So plus or minus g prime. So you just take each of the derivatives. I don't really like that notation, but that's what you do. Product rule. So product rule and quotient rule are the ones that are a little bit harder to remember. So let's see if we can remember them. So the derivative of f of x times g of x is, so it's the first function, derivative of the second, plus second function, derivative of the first. So first derivative of the second plus second derivative of the first. First derivative of the second plus second derivative of the first. Say it a lot, it'll get into your head. So that's how you take the derivative of a product. Quotient rule is going to look like this. So the derivative of, let's say f of x over g of x is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom, and then all over the bottom squared. So bottom derivative of the top minus top derivative of the bottom, all over the bottom squared. Say that a lot, right? Quotient rule has a minus with it. In general, I think subtraction is harder than addition. And quotient rule, so division seems like it should go with minus, and then product is kind of like multiplication going with plus, whatever. However you remember it, you just got to remember them. So you can make up all the problems you want now and take their derivatives. You can check them on your calculator. So this is a life skill that you need to develop. You can check problems that you have made on your calculator. You don't need someone to make problems for you. Just sit down, do it. Just make them look like the things that I've asked you to find the derivative of, and you should be good. So there are two types of lines that feature heavily in calculus. Maybe one more than the other, but maybe not. So they are secant lines. So a secant line is just a line that goes through 2 points on a function. So secant, you have your function, you have point 1, point 2. 2 points on a function is a secant line, which is, I think, the same as in geometry when you learn secants. They're they pass through twice. Tangent so a tangent has a very specific definition. The secant line is just a line that passes through a function twice. Big deal. I mean, they're a big deal, but like that's just algebra 1, like not a big deal. They're important though. Tangent lines, on the other hand, holy cow. Tangent lines you're going to use all the time. So a tangent line, here's the definition. It's a line that has the same slope as a curve at the point of intersection, right? So the point of intersection is called the point of tangency. So that's your point of tangency. And at that point, the curve has exactly the same slope as the line, right? So a tangent line, it shares a value with the function, and at that point, it has the same slope. So could it intersect again? It definitely could. It only needs to be at the point of tangency. Is the slope exactly the same? If so, then it's a tangent line. If not, it's actually not a point of tangency, and so that would be not the right name to call it. But these two lines are going to be like half of your life for a while. So we're going to be writing equations of tangent lines. We're going to talk about where they are. Are they above the curve, below the curve? Secant lines, same deal. Is the secant line above the curve? Is it below the curve? If I plug into the secant line, is it going to give me an overestimate, underestimate? Same for tangent lines. Both of these, super important. You just have to know the terminology. A lot of calculus comes down to knowing the words that someone is saying to you, so you know what to do with those words. So secant line, 2 points. Tangent line, 1 point. Tangent line, the slope is exactly the same as the slope of the curve. So that's what those are. And let's do these problems. So we have f of x is x plus 3 over x minus 6. Find f prime using the quotient rule. So in general, unless someone tells you to use the limit definition, don't use the limit definition. Use one of the rules that we listed up above. So in this case, I see a quotient, I'm gonna use the quotient rule. So f prime is gonna be the bottom. Derivative of the top using the power rule is 1 minus top. Derivative of the bottom using the power rule again is 1 all over the bottom, and then we square it. Okay, so where did things come from? We have a bottom function and we have a top function, right? And so where did things come from? It was bottom derivative of the top minus top derivative of the bottom all over the bottom squared. And then that was bottom derivative of the top minus top derivative of the bottom all over the bottom squared. So that's where everything came from. So f prime of x. So remember, this is telling us the slope of the curve at any value of x that's in the domain. So x equals 6 is not in the domain, so it doesn't have a slope there. Like, why would it? So any point in the domain for this particular function. There are some functions where there are points in the domain at which the slope doesn't exist. This is not one of those. Absolute value of x is one of those. So that's kind of an interesting thing. So this cleans up to x minus 6 minus x minus 3. So negative 9 over x minus 6 squared. So that was x minus 6 minus x minus 3. So negative 6 minus 3, negative 9. Yeah, I think we're good. Okay, so this, I think, is my derivative. So this is going to tell me the slope at any point. And now I think we're going to be asked some questions here. So write the equation of the secant line. Okay, so to write the equation of a line, I'm going to need a slope and I need a point. So we're kind of like given that. Well, we're given the points. Let's find those. So f of 5 is 8 over negative 1, so negative 8. F of negative 3 is 0, actually. So that's good. So then the slope, so let's say slope is going to be f of 5 minus f of negative 3 over 5 minus negative 3, which is negative 8 minus 0. And then over 5 minus, so over 8, so negative 1. And then our line, so our secant line. Secant lines are actually more annoying to write than tangent lines. Like derivatives aren't that bad. You know, there's only so many rules and you follow the rules and you get a derivative, which is really nice. And sometimes you can use limit definition, like almost never, unless you have to do it. So our secant line is going to be I'm going to use, it doesn't matter which point. So I'm going to use y minus -8. So y plus 8 is -1, and then x minus 5. Or it doesn't make a difference. You could have used, so I'm going to write it up above, I guess. Star and then star. Or we could have done y minus 0 is equal to -1, x plus 3. Like either of those would have been totally fine. So we could have gone with this, or you could have gone with this, because they're the same line, right? So what is this? What does the top one simplify to? Y equals -x minus 3. What does the bottom one simplify to? You get y plus 8 equals -x plus 5, subtract 8, y equals -x minus 3. Same line. It doesn't matter which one you use. Which is like, you know, an overlooked thing, I think, in Algebra 1. Like, write the same line in point slope form like 55,000 ways. They're all going to reduce down to the same thing. It doesn't matter which version. All right, so here I need the slope. So that's f prime of 3. So that's going to be -9 over, plug in 3, you get 3 minus 6 is -3 squared is 9. Oh, this is kind of interesting. I got the same slope, so that's cool. And so what's f of 3? Oh, f of 3 we already said. No, we didn't say. F of 3 is 6 over -3. I thought we did -3. I thought I was subbing in -3 again. I got excited. I like when things, you know, I like when a plan comes together. So then our tangent line. So notice I'm labeling kind of like everything as I go. So our tangent line is going to be y plus 2 is -1, x minus 3. Okay, so that's going to be my tangent line. And so, like, what does this all mean? Do I know what this function looks like? Kind of. So let me just like kind of sketch it. So I know at x equals 6, there's an asymptote. I'm going to say this is 0. So if this is 6, there's an asymptote. I know at -3, there's a 0. -3, it's kind of like this. You know, you can do a weird thing with this. You can do this. You can do x plus 3 minus 3. Do I want to do that? No, I want to do plus 6 minus 6. Watch and learn, everybody. Plus 6 minus 6 over x minus 6, which is equal to x minus 6 plus 9. So what I did here was I like cleverly grouped some things. So I grouped x minus 6 and then the plus 9 over x minus 6. So why would I do that? I did that so I can break this up into x minus 6 over x minus 6, which is 1, plus 9 over x minus 6. And now I kind of know what this looks like. So there's a horizontal asymptote at 1. It's 1 over x shifted up 1, and then 6 to the right. So I know what that looks like, which was kind of my goal. I just wanted to know, like, what am I doing? All right, so here's my function. This is not a good rendition because my scale is like atrocious. But -3 and 5. So 5 is like, I'm gonna say 5 puts me like down here maybe, right? So I get a line through those. Let me try to draw this line. And then also at x equals +3. So I guess I kind of, because of the way I'm doing this, I kind of have to say that +3 is like here-ish. I'm doing it so that it looks right, kind of. I should have done this on the calculator, but I feel like we're running. I feel like maybe we're running a little long on this video. That looks terrible. You know what I'm gonna do? I'm gonna do it on the calculator. So if you're interested in this, hang around. Oh no, somehow I activated Siri. Okay, I'm back. Okay. I'm gonna do it on the calculator. If you're interested, hang around. If you're not interested, you know, hit the road. All right, so what to do? I'm gonna graph x plus 3, x minus 6. And then I'm gonna graph the lines, right? So the line was I'm just going to take negative quantity x minus 3, right? Oh, no, negative quantity x plus 3. I forgot that I put the parenthesis. So we get this, and then let me also graph the other one while I'm here, which would be negative 2 minus the quantity x minus 3. Okay, and then I'm going to zoom out so that this looks almost like our picture. You know, we tried, we did our thing. Key thing, you know, the most important thing that I showed right then and there was that plus 6 minus 6. I'm going to use that trick a lot. So it looks like this. I think we did a good job. I mean, I think that I think we nailed it. All right, so I'm going to go back to the notes just so you can see them one more time. I don't really know what the point of doing that is, but I do it on the end of like every video if I don't mess it up. So here's what we did. All right, so a lot of stuff on this page. Make sure you're memorizing just every single thing. Literally everything that you were told to memorize this year, memorize it as soon as possible. Sometimes memorization comes before understanding, and I'm a big believer in that. Like, there's no problem with me if you are first memorizing, then understanding, because if you don't have it, if you don't have access to it, you can't use it anyway. So if memorizing comes first, totally fine. All right, I will see you in the next video when we just keep going. So see you there.